Question 1. A technician at a busy surgery center is preparing the first 270 degrees Fahrenheit steam sterilization cycle of the morning. To prevent initial condensation from immediately forming on the cold internal walls when the cycle starts, which structural component is continuously pre-filled with steam? A. Thermostatic trap. B. Baffle plate. C. Chamber jacket. D. Door gasket. Correct answer C. Knowledge point explanation. Core rationale. The chamber jacket is the outer metal shell designed to hold steam and keep the inner chamber walls heated. This prevents hot steam from condensing into liquid water upon hitting a cold surface, which would create wet packs. Trap analysis. A. Thermostatic trap. This is an internal drain valve that expels cool air and condensate, not a wall heating mechanism. It is correct when discussing the prevention of airlocks. B. Baffle plate. This redirects incoming steam to prevent it from directly striking the load. It is correct when discussing the prevention of steam impingement. D. Door gasket. This is a rubber seal that maintains pressure within the chamber. It is correct when discussing the prevention of cycle aborts due to vacuum leaks. Concept extension. The jacket is heavily insulated on the outside to maintain thermal efficiency and protect the sterile processing staff from severe burn injuries. Question 2. During the daily preventative maintenance routine, a sterile processing technician discovers a brittle, 1-inch crack in the rubber seal surrounding the main entrance of the steam sterilizer. Which component must be replaced immediately to prevent catastrophic pressure leaks during the exposure phase? A. Door gasket. B. Recording chart pen. C. Chamber drain screen. D. Pressure relief valve. Correct answer A. Knowledge point explanation. Core rationale. The door gasket is specifically engineered to maintain a hermetic seal against immense pressure. Any defect allows steam to escape and cool air to enter, rendering the cycle parameters invalid. Trap analysis. B. Recording chart pen. This physical component draws the data lines on the paper printout. It is correct when troubleshooting missing documentation lines on the physical monitor. C. Chamber drain screen. This catches debris from the internal chamber floor. It is correct when discussing the daily cleaning required to prevent clogged drains. D. Pressure relief valve. This is an automatic safety vent that releases excess steam. It is correct when discussing the prevention of structural explosions due to overpressurization. Concept extension. The door gasket must be wiped down daily with a clean, damp, lint-free cloth to ensure microscopic debris does not compromise the high-pressure seal. Question 3. In the architectural design of a standard steam sterilizer, where is the specific component located that serves as the mandatory exit pathway for heavier, cooler air and liquid condensate? A. In the floor of the internal chamber. B. Along the side walls of the outer jacket. C. Directly behind the steam inlet baffle. D. At the top ceiling of the unit. Correct answer A. Knowledge point explanation. Core rationale. The chamber drain is located at the front or center bottom of the internal chamber floor. Because cold air is significantly denser and heavier than steam, gravity forces it downward to this exact exit point. Trap analysis. B. Along the side walls of the outer jacket. The jacket surrounds the chamber to provide heat, not to act as a drain for the internal contents. It is correct when discussing the preheating system. C. Directly behind the steam inlet baffle. The baffle plate is located near the top where steam enters. It is correct when explaining how incoming steam is deflected. D. At the top ceiling of the unit. This is the general area where steam is introduced, not exhausted. It is correct when discussing the initial entry point of the sterilant. Concept extension. Because it handles all the exiting cool air and water, the chamber drain is geometrically the absolute coldest point of the sterilizer, which is exactly why the primary temperature sensor is positioned there. Question 4. An SP technician is troubleshooting a dynamic air removal sterilizer that repeatedly aborts the cycle because it cannot reach the target 270 degrees Fahrenheit. The technician suspects a failure in the temperature-sensitive smart valve that is located in the drain line and is supposed to close only when it detects pure hot steam. What is this specific valve called? A. Pressure-reducing valve. B. Thermostatic trap. C. Steam flush nozzle. D. Mechanical vacuum pump. Correct answer B. Knowledge point explanation. Core rationale. The thermostatic trap acts as the brain of the drain line. It stays open to expel dense, cool air and liquid water, but snaps tightly shut the moment it senses high-temperature saturated steam, thereby trapping the heat inside the chamber to build pressure. Trap analysis. A. Pressure-reducing valve. This regulates the steam pressure coming from the facility's main boiler line. It is correct when discussing steam supply pressure adjustments prior to entering the machine. C. Steam flush nozzle. This is a generic distractor term. It is correct if discussing the actual physical port where steam is injected, not the drain valve. D. Mechanical vacuum pump. This actively pulls air out of the chamber, but it is not a temperature-sensing valve. It is correct when discussing the specific mechanism that differentiates dynamic air removal from gravity displacement. Concept extension. If this trap fails in the closed position, a pocket of cool air is permanently trapped inside the chamber. This creates an airlock that absolutely prevents the machine from reaching the required sterilization temperature. Question 5. Which of the following items provides the legally required physical documentation detailing the precise mechanical parameters, including time, temperature, and pressure, achieved during a specific sterilization cycle? A. The daily Bowie-Dick test sheet. B. The chemical integrator result. C. The cycle charts and printouts. D. The biological indicator log. Correct answer C. Knowledge point explanation. Core rationale. Cycle charts and printouts are the objective physical monitors generated directly by the sterilizer's internal sensors. They provide a permanent written record verifying that the machine reached the exact required physical parameters, which must be initialed by the operator. Trap analysis. A. The daily Bowie-Dick test sheet. This is a Type 2 chemical indicator that only proves the vacuum pump effectively removed air. It is correct when verifying the dynamic air removal system functionality in an empty chamber. B. The chemical integrator result. This is a Type 5 internal response placed inside individual packages. It is correct when verifying that steam actually penetrated a specific dense instrument set. D. The biological indicator log. This documents the actual death of highly resistant bacterial spores. It is correct when discussing the ultimate proof of lethality and the release of implantable devices. Concept extension. Due to strict quality assurance and state regulations, these printouts must be legally retained by the facility for a designated number of years to assist in tracking and tracing potential surgical site infection outbreaks. Question 6. An SP technician at a rural clinic is operating an older steam sterilizer without a mechanical vacuum pump. The technician observes that 250 degrees Fahrenheit steam entering from the top slowly pushes cooler air downward and out through the bottom drain. What type of sterilizer is this? A. Steam flush pressure pulse. B. Dynamic air removal. C. Dry heat convection. D. Gravity displacement. Correct answer D. Knowledge point explanation. Core rationale. Gravity displacement sterilizers rely entirely on the passive laws of physics. Because steam is lighter than air, it floats on top and gradually forces the cooler, heavier air downward and out through the chamber drain without the assistance of a vacuum pump. Trap analysis. A. Steam flush pressure pulse. This uses repeated sequences of active steam injections and pressure releases to mix and purge air, not passive gravity. It is correct when discussing active, non-vacuum air removal. B. Dynamic air removal. This type actively uses a mechanical vacuum pump to forcibly extract air before steam enters. It is correct when the machine uses rapid vacuum pulses. C. Dry heat convection. This describes the heat transfer method in a dry heat oven, not a steam machine. It is correct when processing heat-stable, moisture-sensitive powders or oils. Concept extension. Because this passive air removal process is slower and less efficient at penetrating complex lumens, standard gravity cycles typically require a significantly longer exposure time, such as 30 minutes at 250 degrees Fahrenheit. Question 7. After running a 270 degrees Fahrenheit cycle for 4 minutes, an SP technician reviews a dense 25-pound orthopedic tray and discovers the internal chemical indicator has failed. According to the fundamental rules of thermodynamics and microbiology, what is the most frequent overarching cause for this specific failure? A. Prolonged drying phase. B. Lack of sterilant contact. C. Excessive jacket pressure. D. Optimal saturated steam mixture. Correct answer B. Knowledge point explanation. Core rationale. The golden rule of high-temperature sterilization is that the sterilant must physically touch every single surface. If steam cannot reach the instruments inside a dense tray due to trapped air, improper loading, or bioburden, sterilization cannot occur, making lack of contact the most frequent cause of failure. Trap analysis. A. Prolonged drying phase. Overdrying does not reverse sterility or cause an indicator to fail. It is correct when discussing factors that prevent wet packs. C. Excessive jacket pressure. This might trigger a mechanical safety relief valve but does not directly prevent steam from sterilizing a pack. It is correct when discussing equipment malfunction alarms. D. Optimal saturated steam mixture. Saturated steam, 97% to 100% steam gas, is the exact ideal requirement for success, not a cause of failure. It is correct when defining perfect steam quality. Concept extension. Soil and bioburden act as impenetrable physical barriers that block steam contact, which reinforces the critical decontamination principle that you cannot sterilize what is not clean. Question 8. When evaluating the critical parameters of a terminal steam sterilization cycle, a failure to hold the load at the required elevated temperature for the mandatory continuous duration will directly result in what specific failure? A. An inadequate exposure time preventing the destruction of highly resistant spores. B. A drop in steam quality resulting in severely superheated vapor. C. An extended conditioning duration that overpressurizes the chamber. D. An excessively rapid exhaust rate causing liquids to boil over. Correct answer A. Knowledge point explanation. Core rationale. The exposure phase is the critical killing phase of the cycle. Effective sterilization requires exposing items to the correct parameters for the entire validated time. If this time is cut short, highly resistant bacterial spores will survive the process. Trap analysis. B. A drop in steam quality resulting in severely superheated vapor. This refers to the moisture content of the steam, wet versus dry, not the length of the timer. It is correct when discussing the causes of char or burnt wrappers. C. An extended conditioning duration that overpressurizes the chamber. Conditioning is the phase where air is removed and the chamber is heated before the exposure timer even begins. It is correct when diagnosing a cycle that aborted before reaching sterilization temperature. D. An excessively rapid exhaust rate causing liquids to boil over. This dictates how fast steam leaves the chamber after the exposure phase is entirely complete. It is correct when discussing fluid cycles. Concept extension. There is a strict inverse relationship between time and temperature in steam sterilization. As the temperature increases, e.g., to 270 degrees Fahrenheit or 275 degrees Fahrenheit, the required exposure time drastically decreases. Question 9. If the moisture content of the steam gas drops significantly below the required 97% minimum threshold, the sterilant loses its ability to catalyze protein coagulation efficiently. What is the technical term for this severely moisture-deficient sterilant? A. Low-temperature plasma. B. Wet steam. C. Dry steam. D. Saturated steam. Correct answer C. Knowledge point explanation. Core rationale. Dry steam is the technical synonym for superheated steam. It occurs when steam loses its moisture content, functioning essentially like hot, dry air. Because it lacks necessary water molecules, it is extremely inefficient at killing microbes and will severely burn packaging. Trap analysis. A. Low-temperature plasma. This is a completely different sterilization modality using vaporized hydrogen peroxide, which does not operate at high temperatures. It is correct when processing delicate, heat-sensitive devices. B. Wet steam. This contains more than 3% liquid water and physically drenches the load. It is correct when troubleshooting wet packs, not desiccated or burnt items. D. Saturated steam. This is the perfect, required blend of 97% to 100% steam gas and 0% to 3% liquid water. It is correct when identifying the ideal steam quality required for a successful cycle. Concept extension. Superheating is frequently caused by placing dehydrated or overly dry textile packs into the chamber. The dry fabric acts like a sponge and absorbs all the moisture right out of the chamber steam. Question 10. An SP technician incorrectly removes a warm, wrapped surgical tray from the sterilizer cart immediately after the door opens and places it directly onto a cold, solid stainless steel workstation. Based on thermodynamic principles, what will rapidly form inside the package? A. A biological shield. B. A vacuum seal. C. Superheated vapor. D. Condensate. Correct answer D. Knowledge point explanation. Core rationale. Thermodynamics dictate that when the hot, vapor-filled air trapped inside the sterile package meets a cool, solid surface, the sudden temperature drop forces the vapor to instantly condense back into liquid water. This creates an immediate wet pack, destroying sterility. Trap analysis. A. A biological shield. This refers to organic soil or biofilm protecting microbes during the actual cycle. It is correct when explaining why meticulous cleaning is mandatory. B. A vacuum seal. This is a mechanical condition created inside the chamber by the pump, not a result of thermal shock on a table. It is correct when discussing the pre-vacuum conditioning phase. C. Superheated vapor. This is created by a lack of moisture during the high-temperature cycle, not by placing a hot pack on a cold table. It is correct when discussing boiler steam supply failures. Concept extension. Standard cooling protocols mandate that items must remain entirely untouched on the sterilizer cart in a draft-free, low-traffic area until an objective infrared thermometer verifies they have reached ambient room temperature.